This is Mrs. Pena. We're going to graph a relation. Graph each equation and find the domain and range. Then determine whether the equation is a function and state whether it is discrete or continuous. Part A, y equals negative x plus 6. Making a table of values to graph an equation is a good place to start. You need to pick x values that you think will be okay to graph and find corresponding y values for. You can choose any x values. For me, I'm going to choose -2, -1, 0, and 1. I like to keep things simple, usually start around the origin, and then if I need to go anywhere else, I'll move around from there. Now this means I'm going to take each x value separately, put it into the equation, and find y. So the first x value I'm going to take and write y equals, and in place of x I'm going to put -2. So negative gets recopied from the equation, and in for x I'm going to put -2. When you have two negatives next to each other, putting the number in parentheses make sure that you don't lose the negative sign. Plus 6. The opposite of -2, if you want to look at it that way, is 2 plus 6, which is 8. So the corresponding y value when x is -2 is 8. Now I need to do the same thing for -1. So I'm going to put in -1, y equals the negative sign in front of the x gets recopied. In for x, I put -1, and again I will put that in parentheses so I don't lose the negative signs, plus 6, which simply again gets recopied from the equation. The opposite of -1 is 1, plus 6 is 7. So when x is -1, y is 7. Now I'm going to put in 0. Y equals negative from my equation. If you want to put it in parentheses, no problem. We copy the plus 6. You don't have to, but if you get in that habit, it's not a bad one. The opposite of 0 is still 0. Plus 6 gives you 6. And then when I put 1 into the equation, y equals the negative from the equation. In for x is 1, plus 6 equals, the opposite of 1 is -1 plus 6, and -1 plus 6 is positive 5. So this will be 5. That means that my table will be -2, 8. That point, if I make my scale go by ones each time, I could make this 2 and make this 2. And I like to do a number other than 1 so that it doesn't get lost if I have a grid line there. -1, 7, 0, 6, and 1, 5. I'm going to plot each point separately. -2 for x, 8 for y. That means I go left 2 on my x-axis and up 8. 1, 2, 3, 4, 5, 6, 7, 8. That's my first point. -1, 7 will be the next point. -1, left 1, up 7. And always recount on that second point to double check 1, 2, 3, 4, 5, 6, 7 that you've plotted correctly. 0, 6. So on the y-axis, I will have the point of 6, and 1, 5. Right 1, up 5. This equation represents all of the points that lie on the line that goes through -2, 8, negative 1, 7, 0, 6, and 1, 5. And if you wanted to plot those on your graph, negative 2, 8 is the first point, negative 1, 7, 0, 6, and 1, 5. To find the domain and range of the graph, we need to look at the x and the y values. The domain is the x values that can be put in. The range is the y values that you will get out. In this graph, any x value can be put into this equation to find a y value. If any x value, any real number, can be put in for x and find a y, then your domain for that equation is all real numbers. There's a symbol for this, and it is a capital R with a line through it that represents all real numbers. In this case, for range, I will also get out any y value. If I went all the way down to negative, I could go out, way out to the right, and find the corresponding x value. So my range for this problem is also all real numbers. The graph is a function because it passes the vertical line test. If you drew any vertical line through the graph, it would only intersect the line once. If any vertical line intersects the graph once or not at all, then the graph is a function. So this equation is a function. It is continuous because you can draw it without having to pick your pencil up and continue on to graph the equation. If you can draw an equation and not have to pick up your pencil when you are making it, it's a continuous graph. This is continuous. Part B, y equals negative x squared plus 1. For this problem, one of the things you have to be careful of is the negative outside of the x squared, because negative x squared is not the same thing as the quantity negative x squared. For the left side, you can write this as negative 1 times x squared. The right side is negative x times negative x, or negative x multiplied 2 times. Negative times negative is a positive, and x times x is x squared. So on the right, we would have positive x squared. The left stays negative x squared. So the negative on the outside is something totally different than a negative on the inside of parentheses. Now, I'm going to erase that, and we'll move into solving and graphing negative x squared plus 1. For the squared, any problem that has an exponent that is larger than 1 for the x value, I normally like to try to pick more than 3 numbers, because when it's squared, I usually try 5. And I like to try to stay around the origin, around 0, 0, until I know if I need to move further right or further left. So for this, let's start out with trying x values of negative 2, negative 1, 0, 1, and 2. And if you don't know where to start with x values, those are excellent values to start with. We need to find corresponding y values for those x values by taking them and putting them into the equation and finding y. So let's get started. The first one we'll be putting in negative 2. So I have y equals. I'm going to recopy the negative sign from the problem, put in negative 2 for x, and I'm going to put that in parentheses now because the negative 2 will be squared. Then I'm going to recopy the plus 1. Order of operations says exponents, then multiplication. If you want to put a 1 in here, and multiply -1 times your result, that's fine. You can think of it that way because that's what it means. -2 squared means -2 times -2, which is 4, times -1 plus 1. -1 times 4 is -4, plus 1 is -3. If I put -2 into this equation for x, my y value will be -3. I don't normally write the -1, and the examples that I will do for the numbers from here on down will not have the -1. I'll show you the other way to do it, but that is an okay way to think for this problem. The second value I'm going to put in is -1. Y equals, recopy the negative sign from the problem, put your -1 in parentheses and square it, plus 1. -1 times -1 is +1. The opposite of that is -1. Plus 1. -1 plus 1 is 0. So if I put -1 in for x, I get 0 for y. The next problem will be, put 0 in for x. Y equals, recopy the negative sign from the problem, 0 squared plus 1. 0 squared is 0. The opposite of 0 is still 0. Plus 1 is 1. If I put 0 in for x, I get 1 out for y. The next number I'm going to put in is 1. Y equals, the negative gets recopied, put 1 in for x, square it, plus 1. 1 squared is 1 times 1, or 1. The opposite of that is -1, plus 1, and I get 0. If I put 1 in for x, I get 0 out for y. And the final value I'm going to put in is 2. Go through the same thing that I did for the other problems. Y equals, recopy the negative from the problem, 2 in parentheses squared plus 1. 2 squared means 2 times 2 are 4. The opposite of that is -4, plus 1. -4 plus 1 is -3. If I put 2 in for x, -3 comes out for y. So my points will be -2, -3. Those are my ordered pairs. -2, -3 is the first point that I'm going to plot. The second point, x value -1, y value 0. -1, 0 is my second point. Third point will be 0, 1. Fourth point will be x1, y0. The point will be 1, 0. And the last point that I'm going to plot will be +2, -3, or 2, -3. All of these points are very close to 0, 0, so my scale for my x-axis and the y-axis I will choose to be 1. So I'm going to mark 2 and 2. The first point I need to plot is -2, -3. That means left 2 on x, down 3 on y. Plot that point. The next point that I'm going to plot is -1, 0. Left 1 on x, don't go anywhere on y. That's that point. The next point that I'm going to plot will be 0, 1. Don't go anywhere left or right for x, up 1 for y. The next point is 1, 0. Right 1 on x, don't go anywhere on y. And the last point is 2, -3. Right 2, down 3. And you can see that these points are making a parabola or parabolic shape. So when I connect these points, it gives me a parabola. That's a good graph for this equation. The domain and the range. Domain, again, is your x value. Range is your y value. I can put any number in here for x and find a y value, no matter how large or how small. If that's true, then the domain will be all real numbers. And again, symbol for all real numbers is a capital R with a line through it. Range. The range is the y values. If you look on your graph, the y values above 2 have no graph or no value for x that you can put into the equation to get that y value. For example, if I wanted to get a y value of 4, I couldn't find an x that would give me a y value of 4. My highest y value is 1. That's where my vertex of the parabola, or the top point of this parabola, landed. From 1 down, I can get y values. That means that my range, capital R with no line through it, will be, and I need to make a set of points. The set of, and since it's range, it will be y values, and those y values need to be below or less than, and they can be on equal to 1. So y needs to be less than or equal to 1. That will be your range. Because I can take any vertical line and only intersect this parabola once, or not at all, this equation is a function. And because I don't have to pick up my pencil to draw this graph, it is continuous.